Good morning, good afternoon, good evening, whenever you're watching this video. I hope you're having a good day. In this video, I'm going to address 3 how questions in relation to ANOVA tables. How are they read? How are they interpreted? How are they reported or discussed? So how are they read? Well, if you're not familiar with layered statistics, I would suggest that you consider bookmarking their website. It's a fairly decent website, especially because of the information they will give you on SPSS if you are just now learning how to use that program, or you just need a little refresher course. What they suggest, and I agree, and this reiterates some of the things that we've talked about, is we start with descriptives. Now remember, in analysis of variance, I need to make sure that I have homogeneity of variance. That means the variance within the groups needs to be similar. And I can see that right here, hey, 3.0, 3.3, 3.2, and the total is 3.56. So that's probably fairly close. How do I know? Well, I can then take this value, multiply it by 4, I apologize, by 2, add and subtract it to the mean. And as long as I don't cross 0, if 0 is a true value, then these standard deviations are probably exhibiting homogeneity. It's not a given, but it's not a bad way to start looking at it. Another place to look is at the 95% confidence intervals. If there's no big discrepancies in these 95% confidence intervals, once again, I likely, with no guarantee, but likely do have homogeneity of variance. So that's where these descriptive tables become useful. If I then look at the ANOVA table itself, as I have mentioned in other videos, we always start at the left and we work our way across. That's how we read them. Between groups, that's sum of squares divided by degrees of freedom equals the mean square, because a mean is simply an average. How do I calculate an average? I take the total, sum of squares, and divide it by the number of groups. So between groups, within groups, I read them across. That's all I'm doing. Here's another one. Looks like we've got a Posthoc here, which says Tuki. So they've done some other things. But once again, it hasn't changed anything. Here I am now comparing beginner to intermediate and beginner to advanced. It looks as if the beginner is different from both the intermediate and the advanced. But intermediate is not different than the advanced. And so this is how I would interpret a post-hoc analysis of variance. Well, then the question becomes, how are they discussed? Okay. And the reason why I like layered is because they generally give pretty good examples of how to present it. Now, there's already an issue in this one, a minor one that I hesitate to point out, but will anyway. Here they have written a nice little paragraph. There was a statistically significant difference between groups as determined by one-way ANOVA. And here they give you your F. I've got 2 and 27. Those are my degrees of freedom for the groups and for the sample size. And then give you your value with your p-value. A Tukey post-hoc test, since it's post-hoc, revealed that the time to complete the problem was statistically significantly lower, and I wouldn't put that. I would simply say significantly lower after taking the intermediate and advanced. The reason I wouldn't necessarily put in statistically is actually has nothing to do with statistics, but has everything to do with language. 2 ly words right after one another gets a little sing-songy. If we say that something is significant using statistics, it only means something is statistically different. So if I say there's a significant difference, I am using parlance to say statistically significant in that difference. So this paragraph shows a really good way, shows a really good way to write up a small paragraph describing the ANOVA, describing the post-hoc, and then providing some discussion. I hope this video has answered some of your questions. Hope it's raised some questions. If it has, we'd love to hear them. Otherwise, I hope you have a good day.